do a destroy, but the destroy is really just to clean up old artifacts that we previously built from a previous installment, just to make sure they're wiped out and clean away before we start a new infrastructure. Okay, so that's running. Okay, so it's attempting to clean up old images. It's doing a Docker prune, so it's pruning any containers we had previously created from a previous installment. It will prune them and clean them out, remove them. Any Docker images, so that's done. So we've done a molecule destroy. Make sure, let's see now what we have here. Okay. If you notice, these build kits have been cleaned up and removed. So what we have now on Kubernetes, on our local Kubernetes, is only the core internal Kubernetes pods. Okay. So now that we've done a cleanup, so now we're going to do a molecule reset. So I'm going to say, so we're going to run this molecule reset command. So I'll say make molecule reset. So what this command does, it basically resets the molecule state, right? So if molecule had been installed, had been working from a previous task, it will just put molecule back in a fresh resetted state to assume new operation, right? So now that molecule has been reset, so now I'm going to run the actual molecule-converge command. So this command, what this does, essentially, it does a lot. It clones the code repositories, right? So these code repositories get cloned. Let's take a quick look at those. So we have three main repositories that we're going to be cloning out of this 4 here. So there's an operator, there's a middleware, there's a front end. So the next command, when I issue a molecule converge command, it will clone the code bases for front end application and our middleware application. Right. After it clones those code bases, it will then build this Docker images. Right. So we're building 2 sets of Docker images. We're building images for Ubuntu type machines. We're building images for CentOS. So Red Hat bought CentOS. So CentOS is now called StreamOS. So basically, we're building Docker images for Ubuntu and StreamOS. And we're building them for AMD machines and ARM machines, right? So let me see. Let me fix this here. So this should be... Okay, so we're building the front end application in 2 flavors. We're building an Ubuntu ARM64. This is the new Apple chip machines. We're building the same application for StreamOS an AMD 64 machine. Okay, and this is just so we can test the app on 2 different type devices and 2 different operating systems. So we want to test it on AMD machines. We want to see what the developer experience would look like on a traditional Intel machine, and we want to see what the developer experience look like on an Apple chip machine, right? But we want to do that for the front end application and the middleware application. This front end application here is a VueJS application. The middleware application, that is the Django application, right? So After that, I would actually open up the iOS and the Android mobile applications on an IDE just to see what that looks like. So now, so let me go ahead and issue that command. So while that command runs, we can actually talk more about the details. So the next command to run in this demo is to make molecule-converge. So we're going to be running. Here's our molecule playbooks. We're going to be running molecule-converge, right? So what molecule-converge does, it includes this task called converge, right? And if you take a look at that, what it does, it says converge on Docker desktop, right? So I have a local Docker environment sitting on my laptop. It's called Docker desktop. It has a Kubernetes instance. So let's take a quick look at that. If we go to settings, you see here I have Kubernetes enabled on my Docker desktop. And I've allocated a lot of a good amount of resources to Kubernetes. I gave Kubernetes 10 CPUs here. I gave Kubernetes 28 gigs of RAM. I gave Kubernetes 4 gigs of swap, right? And I'm giving Kubernetes 336 gigs of hard drive space, right? So it's a pretty beefed up Kubernetes for local development, right? So upon that, if you look here, you see right now CPUs are not that busy, but as we start the deployment, they'll start to get busy and more memory will be used. But let's go back to our command. So now I'm going to say make molecule-converge. Make molecule-converge. So this is going to run this molecule matrix. It's going to do a dependency check, right? It's going to run a molecule create. It's going to do a molecule prepare. Then it runs the converge. So it's a matrix. So before it runs the converge, it does dependency check, and it will install whatever resources that molecule itself need. It will run a create scenario. So if you look at this scenario here, it will run dependency check first, then it will run a create scenario, right? If you go in that create scenario, see we don't have it to create anything because we already have a Docker, Kubernetes instance. Then after that, it will say, okay, now that I have a Kubernetes instance, what do I need to create? So it's going to go and say, okay, create all of these images, right? So it will create front-end Docker images. It will create middleware Docker images. So let's go. Let's see how is that coming along. Okay. So right now, what it's doing, we're in this create base image playbook file. So let's go. So that looks like this. Okay, so it's running this task right now. So part of what it does first, it creates a build X instance on the cluster. So if we take a look at our Kubernetes environment, we'll see this build X, this build kit pod has been created, right? So it's 84 seconds old.